Hi and welcome. So we finally got around to work some more or a lot more on the infection solver, and we feel that we are ready to release a new version which we call 2.0. And we got some really nice new features. We first of all have a sub solver which brings all the functionality that you used to from Vellum and Bullet, etc. Excuse me. And we also added groups to all the microsolvers, which really helps a lot when you iterate stuff, and you can choose what part and or what rules that will apply to what effects. And we also reworked the visualization. So now the visualization is on the infection object rather than the infection solver, which makes it really nice because you don't have to recook when you change stuff. So you can change everything from p-scale to other visualization stuff without any kind of hassle. And we also added 2 new microsolvers. One is ice growth. That's similar to what's been done in other places. I know Intagma has done something similar and etc. But now it's simple and fast to use compared to building it by yourself every time you want to use it.
And then we also got a cell split microsolver that can make clusters of density be split into smaller parts when they reach a certain threshold.
And then we also did some setups that gives you a faster way to do common tasks, similar to what the Pyro config has. So we have some simple one-click setups. So let's get started and look at this. So I'm going to start off with the sub solver. So let's drop down a geo node, and we're gonna drop down a grid in there. And from that grid, we're of course gonna scatter some points, make it 100K, because why not? And maybe we bring down the size of this. Let's keep it like this. It doesn't really matter. We got down a group in order to group some stuff here. So just gonna do points, and we're gonna do bounding regions, gonna do bounding sphere. Just gonna bring this down to maybe something like that, maybe, yeah, cool. And 1 second, just gonna bring up my little sheet here, so yeah, cool. So that's good. I keep it one by one, that's fine. So when we've done this, we can of course then give it a bit of density with a wrangle. So we can just choose group 1 here and say at density is equal to 0, 1, I mean. So that's good. Now we have a density, and then we can drop down an infection sub solver. And what we get here is this. So we have everything here as we want to. And we can then of course change visualization, and we have the initial data here, similar to what you have on the initialize. And then we have the solver with all the solver settings here. So we have this all packed into one thing. If you double click, you come into the forces tab. So in here you can simply just drop down let's say infection force, plug it in, make it a bit of a force, maybe 1, and let's change movable to 24, so it moves 24 density per second, which makes it move 1 density per frame, which is kind of what we want here. So you can see it works, it speeds up because we don't have any drag, so let's add that as well just to get something. So we have the drag here, plug it in, make it a bit more maybe. And let's also not add forced empty cells. So now we have something that goes a bit slower and nicer. Cool. So what we can do now is we can change the visualization here. So we can change movable, but all movable is 25. So yeah, L24, so yeah, you get the point here. And we can see also speed, so you can see how the speed has evolved during the thing here, which is quite nice. And we also have tag, but we have not tagged, etc. So we can change all these things and change visualization tab. Yeah, you get it. You get the idea. Cool. So we have that, and that's really nice and neat. But we could also add collisions here, very simple. So let's drop down another sphere here. And let's plug it into collisions and let's move it a bit. So we move it like that maybe do something like this. And then if we enable collisions and hope that things will work now. It does, that's cool. So as you can see, it collides with it and I have to go around it. This is almost like a 2D effect of some kind of grains or something falling. I don't know. Quite nice. Yeah. So that works. And that's really nice. But we could also use the second input to emit stuff. So let's try that as well. Let's bring in another sphere. Let's make it a bit smaller, 0.2. And let's say that the center Z is a sinus function of frame times 5 maybe. And let's also add to the frequency here by multiplying this by 5. Okay, is this too fast? Okay, this is way too fast. Yeah, that's way too fast. So let's say $F only, and let's say by 3. That's fine. I just want something that moves. Yeah, that's cool. So let's plug that into the emission, and let's enable emit from Geo, and maybe do inside. And then on the density tab, we can bring this up. I think it's 24 as well, so we get a lot of density. So what we get now is this. It also emits density and it flows down. Similar to, and then the fuel is out here, of course. And now with visualization, we can look, why doesn't anything come here? And we look at the fuel, yeah, okay, so it eaten up all the fuel, as you can see. Cool. Yeah, that's pretty much it for the subsolver. It's really nice, I really like it. So let's move forward. We have the grouping functions, which we could show here as well, actually. So let's do another group here. We have all our points. Let's drop down a group. And let's just plug it in and use it over points. Keep in bounding regions. And do a bounding box that's maybe around here or something. Let's say that. We call this passive, maybe. I don't know. So we have a group called passive now. And if we now maybe so if we take the infection force and we say, okay, we should have called it active if we wanted, but let's say we do the force not over passive then. So what we can see now is, oh, we shouldn't watch fuel, we should watch density, of course. You can see that it doesn't move when it's in this group. So when this one comes around here and it fills it, it should be still until it moves out of the group. If it ever does, it doesn't. Okay. So yeah, so this is very convenient. And then of course you can do multiple groups here. We can do another group that's, you know, let's do another group that's around here. And we call this growth maybe. And just add a growth here. Plug it in and use the group here. Just to drive this home a little bit too much. We have to go back to start frame. We have all these nice drop down things as well. Quite glad that we took time to do that. You see now growth over the growth group. So this is, I mean, this looks like shit, but it's very convenient in order to, you know, art direct your simulation a bit more. So that's cool. And what else do we got? Yeah, we have the visualization, we have the subsolver of the groups, and then we have the 2 new microsolvers. So let's try that. I'm gonna do a new infection subsolver here, because I mean, I don't wanna delete everything. So now we're gonna show you the cell split wing thing. So what we do, I'm just gonna do a copy of this, maybe. So I'm just gonna give it more relaxed situations to make it a bit smoother here. Maybe to bring it up to even 200, because the cell growth tends to be a little bit more stable with a better distribution of points. So that's good. We could also extract volume if we want to, but yeah. So we have this base here thing, and we're just gonna do a wrangle and say group 1 at density is equal to 1. Cool. And we plug it in. I'm gonna step back to frame 1. Actually, this will be removed, of course. That shouldn't be there. So let's do a growth. And let's do a cell split. And the reason I do a growth is because the cell split in itself won't really give me any... I mean, it splits when it gets a certain threshold. So let's just try it. Let's bring up the threshold here to 1 maybe. And let's see how it looks. So it grows, it grows, it grows, and then it splits up. So one thing you notice here is that this doesn't look really good. And that's because of movable. You need to bring up movable to shit ton, like 25. And the reason for that is because we don't want this in between things. And now you see, now it's actually starting to do things here. So this is pretty much what it does. It grows, and when it's big enough, it splits up. Forms a new cell. And you can see it tries to avoid each other here. That's why you get this kind of separations here. And this one is in between two, so it could become quite flat, which is kind of fun. And we have some settings for this. And basically what we have, you have the size threshold that determines the size, and density, what density is to be counted, and the split force amount is like the explosive force that comes in the subframe or frame when it splits. Separation amount is a constant force that's been added when it's closer than this distance, and this is a multiplier of the average distance between points. So this will have to be changed when you change resolution, when you change things. This is not really, you can't really use the same values for different resolutions. But on the other hand, that's usually the case with all solvers, even though people sometimes say the opposite. So yeah, we also have this relative resolution thing, which is a downsampler. If you bring this higher, it will sample down to make things a bit faster, because this is quite slow and not optimized, but it's very nice. And what we can do as well is we could also combine this with something else. We could simply do, without not using growth, we could just as well use reaction diffusion or whatever. But let's bring down reaction diffusion because I think that's fun. So we should probably have a drag as well, because this adds force, and when you have force, you want drag, usually. So I'm just going to bring a drag, maybe bring it up a little bit. And I'm going to do a reaction diffusion. And this reaction diffusion has to be growth-based, because the density-based tends to override things. It's not really, I think it's complained there, yeah. Density works better over density, more correct result, but tends to override everything else. Growth-based is built to better with other microsolvers. So we use growth-based. I'm glad I can read my own help text, or maybe my colleague Victor's help text here to get things up and running. So let's do the cell split, but let's bring the threshold up to 4 maybe. And let's otherwise just keep it as it is. So let's see what's happening here. So we get this, it grows out, it's doing this reaction diffusion thing. And when it gets big enough, it splits. And that's quite fun, I think. I don't know, it's not like the most fun thing I've ever seen, but it's like a moderate amount of fun going on here. So that's kind of nice. It works quite well with that. And you can bring up the sub-steps to get a clean result, etc. as always. And not as always, but usually. So that's the cell split. I really like it. I think it's fun, although I don't... I mean, I've been struggling a bit to see how I'm gonna use it in production. But yeah, fuck that. I mean, it's fun. That's what matters, right? So cool. We also have another solver that I really think is super useful, and that's snow growth, ice growth thingy. So let's drop down. We can actually use this, I think. We have this thing here going on. So I'm just gonna do another copy, because I can give you the hip file if you would ever need it. It's very simple, so I don't think you need it. So what I'm gonna do now is I'm gonna do the same thing, but I'm gonna start off with doing some things differently. We need 1 point only instead of the group here. So what if, do I have like a preview on? Okay, it's the relax. It hasn't done the relax. Yeah, okay, cool. So we're just gonna do 1 point here instead. So, no, come on. It has primitive selected. So there's 1 point. That's cool. So that has a density of 1. But the thing with this, it's gonna remove everything else in here. Oh, sorry, I removed that. Doesn't matter. The thing with the ice growth is that it needs background density values, because it kind of eats up its surrounding neighbors. Kind of like that, you know, I don't know who does that. I don't know. Cannibals, I guess. In order to have food for it, we need to plug in some kind of density to the cells around. So I'm just gonna start with just giving all cells value of 0.4. This could of course be randomized to give it a little bit more random look. So when we're done that, we're kind of happy with that. We have one cell that's white and the other cells are 0.4. So let's drop down the infection ice growth, plug that in, and what we have here are not that complicated. We have an amount, we have a constant growth on weight, and these change things a little bit, but the most important thing to consider here is the point distribution. The point distribution is what gets you regular or irregular growth. So you can see here we have 1 point surrounded by 6 points. If we then set the initial data here to look at 7 points, because it includes itself, we will have kind of a regular growth, not as regular as one might want, but yeah. And also this, I think if we just play it now, it will break. Whoa, looks weird. It looks cool, but weird. So bring it up to 3 substeps, stabilize things a lot. As you can see here, we get quite nice growth. We have 200 relaxed iterations, so it kind of gives us a snowflakey look. I kind of like this distribution, but if we want something that's really, really, you know, regular, one would need more hexagonal distribution. So in order to make that a bit faster, we actually did, and that brings us into our last subject, the quick setups. So we have an infection configure ice growth here. If we just bring that down, you will see that we get everything configured here for the ice growth. But it's gonna steal because we have a computed dual here thing. So it's gonna take this. So we get exactly the same thing here. So you can see that I'm not cheating in any way. So it's gonna have the same thing, but I'm bringing in this dual thing that we just keep the points for. I guess you know how to do this yourself. If you don't, I'm gonna show you. Like if you have a pig head, you can do, if you want this to get a hexagonal distribution, you can do a divide. And you can then compute dual. So that gives you this. Of course, you have a very uneven distribution. I show that as well. So, I mean, if you want it more even, you have to remesh it first, of course. And yeah, you probably want to bring the target size down. But yeah, that's how you can go about to get this kind of distribution. So this is probably what you will need to do before using the ice growth if you want like a very even distribution. So you just use your mesh. And this will start taking time. When you have a high resolution, this is super low resolution right now. When you have this high resolution, this divide thing takes forever. But I haven't found any way around that, so that's probably worth it. But if you just want to test with a grid, we have this set up. So now we have this. It's a bit high resolution, and it's gonna do. So therefore, I'm gonna bring down the sphere size to even smaller, 0.5. No, you can see here how it looks. I think that's interesting to see actually. So what we want to do here is we actually want to look at 10 points, I think, but you can do this differently as well. So if we bring it up to 10 points here and look how that works. Because that gives us, I think that gives us like 2 rows away with neighbors. And that gives us, if we start zooming out here, we will start to see maybe I need to, yeah, it's kind of hard to see. We don't maybe do black background here instead. Yeah, as you can see, we get this kind of very even snowflakey growth, which is fun. And just to drive this home, you can see what happens if we can do like, let's say that we only look at, we have actually 3 points around everyone. So let's see what happens if we bring this down to 3. I haven't tried it. It will probably just be weird. It's kind of weird, kind of slow growth. So you see this kind of changes everything. So let's bring this up to 5 and see what happens. And you see you get a completely different result. This doesn't, yeah, it starts to look something like a snowflake, but it gets, I guess, depending on how it starts and how distribution is. So, I mean, this is what to work with if you wanna. The problem is that this is set by the start. So if you wanna override this, you have to write your own custom code if you wanna change it during the simulation. It's not that hard. It's actually an attribute called near, I think it's just called near PTS. Yeah, so basically this array near points, you can overwrite this to set, because this it will only look over these points. So if you just do a wrangle and overwrite the near points, you can do this dynamically if you want to change it during the simulation. So yeah, but also bringing up to higher level value is kind of fun, because it kind of gives you this kind of thing going on. I'm just gonna bring up the p-scale a little bit to show things a bit more here, I think. So you get this kind of thing going on with this modular kind of look, which could be quite fun for things as well. I thought bringing this into height fields as well, just to look at it. I haven't done that yet, but I think it could be quite cool. So yeah, that's this is kind of a fun distribution as well. Yeah, so that's pretty much it. We have some other quick setups as well. I can just show you that. So we have, if you just write configure, infection configure, you see we have animation, base, ice growth, emit from year, and reaction diffusion. So like animation is just to show you how you could set up animation with the post tools here. So you have like infection p-scale animation here, and you have a copy to points here. And if we just play this, you will probably see, yeah, we have this kind of teapots and things growing up as the simulation moves along. So it's just a very, you can see the animation here, it's just very basic. But this kind of get you going with the tag tools and with animation tools. So what you can do here is you can see, I mean, you can do weird shit here as well, of course. Like just to try this out, you can see that how it, this will just be weird, of course. Go up and go down. Yeah, but yeah, you get the point here. So this is quite nice. And then you can, of course, bring animation in with this. But I have another videos on that. You don't have to go through that today. Yeah, so we have all these setups, and we also have it for, yeah, like the base and reaction diffusion stuff. But that's it. If you like this and if you use this, especially if you use it professional, we would be super happy if you could help us out with donating a little bit of money when you download it, because this is quite a lot of work and we want to continue doing it, and that becomes a lot easier with a little bit of money. We have a lot of people that have been very generous, and I'm super grateful to you guys. And also you can follow us on Instagram. We just call Infection Solver in one word. And yeah, we are both on YouTube and Vimeo, I think. Yeah, never mind. Thank you for watching, and bye.